Hello everyone, happy to meet you again in another lecture. Learning mathematics is a pleasure. I am Dr.P.Santhi, Assistant Professor of Mathematics, the Standard Fireworks Rajaratnam College for Women, Sivagasi. In this lecture, let's know about characteristic equation and Cayley-Hamilton theorem. So it is one of the key concept in linear algebra. The learning objective of this lecture is to know about what is characteristic equation and what is Cayley-Hamilton theorem, and then its usage in matrices and also some sample problems in GATE exams. Finally, we will learn about its applications in other fields. So, first we will learn about characteristic equation. So, before to know characteristic equation, first we define characteristic matrix. The characteristic matrix for the given matrix A of order n is defined as A minus xi, and its characteristic polynomial is defined as determinant of A minus xi. And then finally we come into our concept, characteristic equation is defined as determinant of A minus xi equal to 0. Here I is the identity matrix of order n. Now let us know what is Cayley-Hamilton theorem. It states that every square matrix A satisfies its characteristic equation. That means if A0 plus A1x plus A2x plus etc. plus An x power n is the characteristic polynomial of degree n of A, then A0 I, that means A matrix satisfies its characteristic equation, that is in the place of x we can replace as A. Here A, if the order of the matrix A is n, we have to consider the identity matrix is of order n. So, this is what Cayley-Hamilton theorem. Next, let us see its usage in matrices. What is the use of this theorem for finding some of the results in matrices? The first one is finding inverse of a non-singular square matrix A, that is finding A inverse. So, in previous classes we know how to find A inverse in different methods. Here this is a new method by making use of Cayley-Hamilton theorem. Another usage is finding the higher powers of A, that is finding A squared, A cube, A power n etc. with the help of Cayley-Hamilton theorem. Let us see these things with the help of some example. So, major question is how to verify Cayley-Hamilton theorem. So, what Cayley-Hamilton theorem states that every square matrix satisfies its characteristic equation. Here we consider a 2 by 2 matrix. Let us find its characteristic equation and then let us check whether it satisfies or not. Its characteristic equation is determinant of A minus lambda I equal to 0. So, A matrix minus lambda into identity matrix gives us the same matrix with the diagonal entries is its difference 1 minus lambda, 3 minus lambda. Its determinant AD minus BC gives 1 minus lambda into 3 minus lambda minus 8. By simplifying this we will get the characteristic equation lambda squared minus 4 lambda minus 5 equal to 0. Now let us check whether this characteristic equation is satisfied by the matrix A. That is to prove A squared minus 4A minus 5I equal to 0. By usual matrix multiplication we can get A squared as the matrix 9, 8, 16, 17 and 4A and 5I we can get by usual techniques, and then we substituting the values of A squared, 4A and 5I, we will get the result as a 0 matrix. Hence, we verified that a square matrix satisfies its characteristic equation. Yes. Next, let us see another example in which we can find the A inverse and A power 4, that is inverse of the given matrix and higher powers of A. So, for that first we find characteristic equation by usual technique. For the given matrix, the characteristic equation is lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. From this matrix, we can get A inverse by this technique, that is keep the last entry by Cayley-Hamilton theorem, where we can replace lambda as A. From that equation, we get 4i equal to A cube minus 5a square plus 8a. Then pre-multiplying by A inverse on both sides, we will get 4 into I into A inverse is nothing but A inverse. Similarly, 1 power of A is reduced in the right side, that is A square minus 5a plus 8i. So, already we have the values for A squared, A and I. Just by replacing all those values, we will get A squared as A 1 0 minus 6, 6 4 12, 0 0 4, and then A inverse equal to 1 by 4 into replace its values. We will get the answer as 1 by 4 into 4 0 4, 4 2 minus 8, 0 0 2. So, this is one way of finding A inverse with the help of Cayley-Hamilton theorem. Yes, next let us find A power 4. For that you consider the characteristic equation and the Cayley-Hamilton theorem. So, considering the equation 1, we get this result. Now, you pre-multiplying both sides by A, we will get A power 4 equal to 5a cube minus 8a square plus 4a. Then rearranging the given result by with the help of the previous result. In the place of a cube, you replace the previous result 5a square minus 8a plus 4i. So, by simplifying this, we will get a power 4 as 17a square minus 36a plus 28. So, already we know the value for a squared, a and I. Just by replacing all those values, we will get the answer for a power 4. So, this is the result. 1 0 minus 30, 30 16, 60, 0 0 16. So, in the similar manner we can get the any higher powers of A with the help of Cayley-Hamilton theorem. Yes. So, this is one gate question in this concept, that is given a matrix A is minus 5 minus 3 2 0, a 2 by 2 matrix is given. They are asking the higher power of A, that is A cube. So, A cube answer is given in 4 answers. We can check the correct answer with the help of Cayley-Hamilton theorem. So, for that first you find the characteristic equation of the given matrix A, that is we give lambda square plus 5 lambda plus 6 equal to 0. We know that Cayley-Hamilton theorem satisfies its characteristic equation. That is why we can replace lambda as A. That is why A square plus 5a plus 6i equal to 0. That implies A squared equal to minus 5a minus 6i. That implies A cube can be, by pre-multiplying by A, we get A cube as like this. So, from that we get the answer for A cube as 19a plus 30i. So, from the given question, we observe that option B is the correct answer, 19a plus 30i. So, we can able to solve similar questions in gate problem or CSIR problem with the help of Cayley-Hamilton theorem. Finally, let us see some of its applications in Cayley-Hamilton theorem in various fields of mathematics. The Cayley-Hamilton theorem is used to solve the system of linear equations and also system of linear differential equation, and also in control theory it is used to solve the controls linear systems, okay, used by Cayley-Hamilton theorem. That is all. And also in addition cumulative algebra also it is utilized. Yes, thank you.